Previously, we showed that if you have the limit as x goes to 0 of the quotient of two functions, and you know that both of these functions evaluated at 0 give you 0, we found out that this equals the limit as x goes to 0 of the quotient of these two functions' derivatives. So what we would like to do this time is show what would happen if we have x being equal to something other than 0, or a. So this time we have the limit as x goes to a value a, any finite value a, that is, of f of x over g of x. And this time we know that f and g are both 0 at x equals a. And we would like to show that this equals to the limit as x goes to a of the quotient of these two functions' derivatives, provided that this limit exists. So we don't know how to handle x going to a, but we do know how to handle x going to 0. So I'm going to take a look at the limit as x goes to a of f of x over g of x, and I'm going to make a substitution because I'd like to have a limit with some variable going to 0. So I'm going to take a new variable u, and I'm going to assign it to be x minus a, because that way, as x goes to a, u will go to a minus a, which is 0. And while I'm at it, let me add a on both sides so I can solve for x. So x will be equal to u plus a. So I can say that this is the limit, and u will be going to 0. We have f of x, which is going to be our u plus a, and g of x, which is also u plus a. And as u is approaching to 0, the numerator is approaching f of a, and the denominator is approaching g of a, and we know that these are both 0. So by what we proved last time, we know that to evaluate this limit, we can differentiate the top and the bottom. So we can say that this is the limit as u goes to 0, and I'll just differentiate the top and the bottom. So I'll get f prime of u plus a, and using the chain rule, we multiply by the derivative of the inside here, but the derivative of the inside here is just 1, because a is a constant. And likewise, in the denominator, we will have g prime of u plus a. But let me write this better. And now I'm just going to put u back as x, so we can get back to this. So we know that u was x minus a, so we know that x was going to a. If u is going to 0, then x is going to a. We have f prime of u plus a, which is just our x, and g prime of u plus a is also our x. And we have proved that this equals this, which is what we wanted to prove.